Hi, my name is Niels Visgon. I'm in the 850 section, and today I'm going to show you how to calculate Kp for a given reaction and given certain values. So over here, we have the problem. In the gas phase, formic acid forms a dimer. That is this reaction, 2HCOOH in gas form forms a dimer into that. They tell us that at 25 degrees Celsius, we have our enthalpy value, delta H standard, is 60.1 kilojoules per mole. Our delta G value, our free energy value, is minus 13.9 kilojoules per mole. The question is asking, what is Kp at 75 degrees Celsius? So for here, we have to take it in parts. What do we know? We know that this is an exothermic reaction. We have delta H is less than 0, and we have a spontaneous reaction. Delta G is also negative. But as we know, we can't determine everything based off of just that. And if we want to know what Kp is, we know that at a different temperature, our delta G is going to be different. Because as we know, spontaneity is dependent on temperature, not just enthalpy. So how can we solve this? Well, we need an entropy value. We need delta S. But how can we find delta S? Well, let's derive a way to come up with it. We know that for a certain temperature, delta G equals delta H minus T delta S. If we arrange that, we can get delta S equals delta H minus delta G over T. So this is going to be a really important equation for us. But considering that we're using T, we need to convert our Celsius into Kelvin because all of the units that we're using don't actually matter for Celsius. So how can we convert 25 degrees Celsius and 75 degrees Celsius? Well, let's add 273. If you want, you can put this on your calculator, but you should get 25 plus 273 equals, I believe that answer is 298 Kelvin, of course. And 75 plus 273 equals 348 Kelvin. Okay, so we have our values in Kelvin. What next? Well, now that we have all of our things, we can sub in and we can get our delta S. So delta S equals delta H minus 60.1 kilojoules per mole minus our delta G value, minus 13.9 kilojoules per mole. We want to divide this all by T. Our T at 25 degrees Celsius or 298 Kelvin for this. So let's review. If we take our delta S, units should be in kilojoules divided by moles times Kelvin. That makes sense. That's a familiar term for us. If you do this math, we should get delta S equals minus 0.155 kilojoules per K mole. Yeah, so we're in good shape. We have our entropy value now. Why is that ultimately important? Well, unlike delta G, for instance, delta S is independent of temperature. So now that we have delta S, we can calculate our delta G for the newer temperature, and from there we can find K using another formula. But let's take it one step at a time. Let's use our new delta S value. We're going to move to this other board over here because we're running out of space. So, now, at 348 Kelvin, delta G, which is what we're looking for at this new temperature, delta H minus T delta S equals minus 60.1 minus 348, and our value for that, 0.15 kilojoules mole K. As we see here, K and K should switch out, and our new delta G values we put inside your calculator should give you minus 6.15 kilojoules per mole. What else can we do with this? Well, if we're looking for K, we know there's another formula available for us. And that is delta G equals minus RT ln K. What is R? R is 0.314 joules per mole K. So as you might be able to tell, we've run into a problem. We have this in terms of joules per mole K, but our delta G is in kilojoules. So let's take our delta G and turn it into joules. Okay, now we're gonna multiply, do some quick stoichiometry. Now we're in joules per mole K. That's equal to minus 6,150 joules per mole K. Okay, we're just about set. We can pretty much solve it all now. Minus 6,150 joules per mole K equals minus 8.314 joules per mole K times T, 348 Kelvin, ln K. If you do some quick math, we will get ln K equals 2.12. And yeah, don't forget guys, when you're dividing RT, we're taking this RT and put it under here for that term. When we're doing that, make sure to carry over the minus signs. If your answer is negative, everything's getting messed up. How do we get K from here? Well, K equals E to the ln K. So E to the 2.12 power gives you an answer of 8.3. Okay, so that's your answer. Depending on how you rounded, you may get in that area, but 8.3 is what you want to get. So in summary, the main parts of this is that delta G changes with temperature. If you get that idea and you understand that you can calculate entropy at any temperature value, like we did here, we found entropy, we carried it over to the new temperature, found our new free energy value of minus 6.15, did a little bit of converting, but in the end, if you do that, you can find ln K just by finding your entropy, stuff like that. Alright, that's pretty much it, and thank you for watching.